Hello everyone, in this video we're going to be solving a radical equation. We have the square root of 1 minus x squared equals 3x minus 4x cubed, and we're looking for real values of x. So, as with pretty much every radical equation, if you square both sides here, you get rid of the radical, and you get something like this. 1 minus x squared equals, that expression squared is going to be 9x squared minus 24 x to the 4th power plus 16x to the 6th power. And then if you put everything on the same side, you get 16x to the 6th power minus 24x to the 4th power. If you bring over the negative x squared, add x squared to both sides, you're going to be getting 10x squared, and then minus 1 is equal to 0. As you know, this equation has degree 6, and we don't really have any formula for anything quintic and above. So, this is not a very good way to solve this problem. We're going to be using a different approach. And that approach is actually very, very radical. Or should I say, trigonometric. Okay, so we're going to use trigonometry to solve for x. So let's assume that x is equal to sine alpha. Now you might be wondering, like, how on earth could you just assume that? Because sine alpha is between -1 and +1 inclusive, right? Well, if you look at this equation carefully, you're going to notice that the domain gives us pretty much the same thing. For example, if you look at 1 minus x squared, obviously 1 minus x squared needs to be greater or equal to 0, which gives you x squared is less than or equal to 1, which gives you the absolute value of x is less or equal to 1, which means x is between -1 and +1. So this actually perfectly fits with sine alpha. So that's good. But not only that, we also have another condition, because our radical equals a cubic expression. That cubic expression, the result of the square root, should not be negative either, right? So we can also say that, at this point, 3x minus 4x cubed needs to be greater than or equal to 0, because we're looking for real solutions, right? So how can we handle this? This one was kind of easy. We know that x needs to be in that interval, but there's more to it. So we can just go ahead and factor out x here. That gives us 3 minus 4x squared is greater than or equal to 0. And then for this expression right here, I'm going to make a table. If you look at the roots of this polynomial, you're going to be getting 3 roots. 0, and then you're going to be getting something like the square root of 3/4 plus minus. That's going to give you square root of 3 over 2. So we have the following. Negative root 3 over 2, 0, and root 3 over 2. I'm going to be using the method of intervals. So here I'm going to put my expression and look at a table how the sign changes. Obviously, when you look at it, like as x approaches negative infinity, the function is going to approach negative infinity. So I have a negative sign here, and then it just changes every time because these are valid roots, right? Plus, minus, and plus. Now, what am I looking for? Well, we're looking for the values of this where it's non-negative, greater or equal to 0. In other words, we're looking for this interval or for this interval. Now this tells you that x needs to be less than or equal to negative root 3 over 2, or x needs to be between 0 and root 3 over 2. And of course, we also have the condition x needs to be between -1 and 1. And if you put these together, now notice that -1 is going to be here, right, in our table, and +1 is going to be somewhere here. So when you look at the intersection of those two things, then you're basically going to be getting, you're not going to, well, you're kind of getting this part here, right, obviously. So this part here is, since we're looking for between these two values, you're basically looking at part of this expression right here. So this is completely included, and then here only this piece is included. Okay, so that's what we need to pay attention to when we're finding our solutions, and I'm going to check that when we get there. Okay, great. So having said that, let's go ahead and do our substitution. Well, we said that x equals sine alpha is going to solve the problem. Let's go ahead and substitute that. It's going to give me 1 minus square root of 1 minus sine squared alpha, and on the right hand side 3 sine alpha minus 4 sine cube alpha. Of course, the substitution that I use here is not only just because 1 minus x squared, but also there's something nice on the right hand side. Well, if you know your identities, and I think you should know your identities definitely if you're dealing with trigonometry or some radical equations like this one, notice that this is going to be something well known. Well, it is equal to sine 3 alpha. triple angle formula. And you can easily prove this by writing sine 2 alpha plus alpha and then using the formula, so on and so forth. But what's interesting on the left-hand side is that this is not just going to be, cosine, but it could also be the negative of it, right? So basically what we need to do here is write this as the absolute value of cosine alpha, and then it equals sine 3 alpha. And where does that come from? The famous or the infamous Pythagorean identity, 1 minus sine squared is the same as cosine squared. Okay, now we do have this equality. Let's go ahead and look at two cases here. The first case is where cosine alpha is greater than or equal to 0. In that case, we're going to have something like this. Cosine alpha is equal to sine 3 alpha. Great. So we're going to be solving an equation. Obviously, there's so many ways to solve this problem. You can use the formula if you want, but that's not very good. You can maybe turn one of these into sine or cosine or vice versa. But I'm going to use the cosine here. So let me go ahead and write the right-hand side, as a cosine. How do I do that? Well, subtract the angle, the argument from pi over 2, and you'll get it because we have that identity, right? Pi over 2 minus alpha. If you cosine it, it's going to be the sine of the same angle. Okay, great. Now, this is a cosine equation, and it can be solved in two branches, right? As you know, one of the branches is going to be like this. We can just set them equal to each other. We can safely say that, well, alpha is equal to pi over 2 minus 3 alpha plus 2 and multiply by pi. Of course, we can add even multiples of pi here because 2 pi is pretty much equivalent to 0. Okay, but my goal is to solve for alpha. Let's go ahead and add 3 alpha to both sides. That's going to give me 4 alpha is equal to pi over 2 plus 2 and pi. I hope I'm not going too fast here because I want to make sure that everybody understands this and it's clear. So 4 alpha is equal to that. Let's go ahead and divide both sides by 4, and that should give me pi over 8 plus, of course, if you divide that by 4, you're going to get something like n times pi over 2. You're basically starting with pi over 8 and then adding multiples of pi over 2, or just adding 4 pi over 8 every time. So it's going to go like this. Well, first alpha is going to be pi over 8. Let's go ahead and take a look at that, and then we're going to look at the second branch later. Okay, let's go ahead and finish this up first. So from here, if n is equal to 0, basically, if n is equal to 0, then I'm getting something like this. Alpha equals pi over 8. Now remember, our goal is not to solve for alpha, but to solve for x. But remember, x is equal to sine alpha. So from here, I can say that, okay, x is equal to sine alpha. And so x is equal to sine pi over 8. And what is sine pi over 8? Well, it's equal to something interesting. Square root of 2 minus root 2 all over 2. That's the value of sine 22.5 degrees. In other words, you can draw a right triangle and just find it very easily. Or you can use one of the double angle formulas. Okay, great. So is that going to work? I'll tell you at the end. Let me go ahead and finish up all these cases. N equals 1 is going to give me alpha equals 5 pi over 8, because remember, every time we're adding 4 pi over 8 because it's pi over 2. Every time for n equals 1, I should be getting this. And x is going to be sine 5 pi over 8, which is equal to the square root of 2 plus root 2 over 2. All right? For n equals 2, I'm going to be getting alpha equals 9 pi over 8. And then from here, x is going to equal sine of 9 pi over 8. And then that is going to equal negative. Notice that this is in the third quadrant, so it's going to have a negative value. And interestingly, this is going to be just alpha pi plus alpha. If you look at this, pi plus pi over 8, it's just going to be the opposite of that. And this is going to be my value. And finally, for n equals 3, because n equals 4 is going to bring you back to square 1, so we don't need to use that. So alpha is going to give me 13 pi over 8, and then x is going to be sine 13 pi over 8, and that is equal to the opposite of sine 5 pi over 8, because their difference is pi. So it's going to be the opposite of the square root of 2 plus root 2 over 2. Now we got to look at this very carefully, because we had some conditions at the beginning. Remember, we said something like, okay, x needs to be in this interval, or alpha needs to be in a certain interval, right? Well, in this case, we're going to reject any value that falls here, or here, or here, because they are not in the domain. So let's go ahead and check that out, and I've done it for you actually. If you do the checking, you're going to notice that this is a valid solution for x. That's going to work. And of course, this is going to work as well, because it's within the boundaries. But unfortunately, this guy here is greater than root 3 over 2, so it's just not going to work. We have to reject it. And this guy here is greater than negative root 3 over 2. Notice that they're not opposites, they're different values. So that's going to be rejected as well. So we only get 2 solutions from here. And then the next thing we're going to do is the second branch of this. Remember, we said that it's going to branch off into 2 things. And let me go ahead and write down the second branch where we change this angle into its opposite. Because remember, cosine is an even function, and cosine of negative x is the same as cosine x. So it doesn't matter if you change the angle x to negative x inside the parentheses. Okay, great. So now my second branch is going to look like this then. I'm going to have something like cosine alpha. Let me write the original equation because from here it's actually easier to manipulate. So this was my first branch, but what I'm going to do now is reverse the second one. So it's going to be negated basically, and it's going to give me this one. Great. Right? We just multiply everything here by -1 because that's what cosine is. Okay. From here, what am I going to do? I'd like to start here because that's where I have more alpha. So I'd like to write that on the left-hand side. It doesn't really matter. You can just switch sides. So 3 alpha minus pi over 2 is equal to alpha plus 2n pi. Of course, in this case, n is not going to be the same n. Well, it doesn't really matter because at the end we're finding the actual solution. So, I mean, if you want, you can use k. It doesn't really matter. No big deal. Let's go ahead and change it to 2k pi. Okay, great. Now, what I'm going to do is I'm going to put the alphas on the same side again. So, subtract alpha. 2 alpha is equal to pi over 2 plus 2k. I can't even write 2k. Okay, 2k pi. All right. So now let's go ahead and divide both sides by 2, and that's going to give me a different angle. Notice that I'm getting pi over 4 this time. Of course, the solutions are going to be different. Oops, a graph is coming up. I didn't anticipate that we're going to get to this. We're going to get to it this quickly because I was going to show you something on the graph. But what we need to do is basically just skip that part, and we'll get back to it later. But let me go ahead and just write the solutions here, and I'm going to give you what happens, and then hopefully maybe we can look at the graph after this, and then after the graph I'll show you the other solutions as well. Okay, great. So let's go ahead and write down what's going on here. So I have this solution, and I'm going to replace k with 0, 1, 2, and 3. So if you replace k with 0, for example, you get alpha equals pi over 4, and of course from here x is going to be sine pi over 4, and that is going to be root 2 over 2, right? That's going to be basically my solution. Is that going to be a valid solution? The answer is yes. Root 2 over 2 is actually going to work. Okay, great. So that's another valid solution because when I checked it, it did check. Let's go ahead and look at other solutions here without going into the next page, okay? If you don't mind. Well, if you replace k with, what should I say? If you replace k with 1, by the way, I said k equals 0, 1, 2, 3. That's not right. K can only be 0 or 1 in this case. If we're trying to find the solutions from 0 to 2 pi, by the way. But if you want the general solutions, you got the general solutions, so please don't complain about it. If you want to complain about it, that's fine too. I don't mind. Okay, anyways, I talk too much. I know that, so let's move on. So alpha is equal to 5 pi over 4. And from here, I should be getting something like x is equal to sine 5 pi over 4. And that is going to be negative root 2 over 2. But unfortunately, negative root 2 over 2 is greater than negative root 3 over 2 because root 3 is greater than root 2, so the opposites are the other way around, so on and so forth. And this solution is going to be rejected as well. Okay, so we're only getting one solution from this branch, and if you put it all together, we're going to be getting all the solutions. But this is not the whole story. Remember, we also had, when we talked about the absolute value here, we said that, okay, we also have a negative value, right? Because we look at the absolute value of cosine. So what about the negative cosine? Well, let me tell you something, if you don't mind. If you do the expression that way, so let's say you're looking through this. Okay, so what if negative cosine alpha is equal to sine 3 alpha, which can be written as cosine of pi over 2 minus 3 alpha. Let me just show you a little bit of this. Well, cosine alpha can be written, negative cosine alpha can be written as cosine pi minus alpha, because you can't really write it as cosine of negative alpha because alpha cosine is even. Therefore, you can only write it this way. I hope I'm not talking too fast because I don't want to make this video too long. Anyways, let's just get this done. So here you can set them equal to each other, find the alpha values, but guess what? You're going to be running through the same values. So what's the point, right? I'm telling you that you're going to be hitting the same values and some of them are not going to be valid. So I got these values so far. I got this one, I got this one, and I got this one. So I got three solutions. Are you convinced? If you're not convinced, Here's the graph. Here you go. Awesome. We have the graph of the square root of 1 minus x squared. As you know, that's a semicircle. It's intersected by the cubic function 3x minus 4x cubed. And you can test this in Desmos and then see where the solutions are. We have 2 positive solutions and 1 negative solutions. Let me go ahead and rewrite those solutions, and we're going to go ahead and finish up. So here's our solution set. Our solution set is made up of square root of 2 over 2, the square root of 2 minus root 2 over 2, and then the opposite of the square root of 2 plus root 2 over 2. And this brings us, okay, that's fine, you can see the graph. That brings us to the end of this video. Well, thank you for watching. I hope you enjoyed the video. Please let me know. I apologize for the lengthy video. It's really hard to keep this video short because there's a lot of things we talked about. Hopefully that wasn't too fast. Please let me know what you think. Don't forget to comment, like, and subscribe. As always, I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.